Hello everyone. Today I'm going to start my new channel, videos of my new channel regarding CSIR net physics. This is my starting video. So, today we shall start discussing the topic electromagnetism that frequently comes in CSIR net and different kinds of such competitive exams in India. So, first of all, we shall talk about the syllabus of CSIR net or in different kinds of exam that frequently appears, the questions that frequently appears from different parts of electromagnetism. So, this I shall take the contents I shall take from a book of Ajay Ghatak, and the contents are coordinate system and vector algebra, the Dirac delta function and Fourier transform, Coulomb's law, electric flux, Gauss's law, Laplace equation, and you can see different names of chapters that actually comes in net set or gate exam or different kinds of such competitive exam. So today we shall be going to start the chapter electromagnetism, that is Coulomb's law. The first part we shall start Coulomb's law, and later on we shall do different other chapters and Dirac delta function, coordinate system. These chapters will also be included in the syllabus of electromagnetism. So in my starting video, I'm going to start Coulomb's law. So first, I think you can you are being able to see uh, the page, namely Coulomb's law, Coulomb's potential. Different kinds of formulas are given here over the page. So these are some important formulas and important physical values that you should paste in your mind, paste in your brain while going to net center or any kind of such exam center, because questions from these what can I say, based on these formulae comes apparently. Okay, so the first numerical that actually I have written down is: consider four equal charges plus q located at the corners of a square on the xy plane with side 2a. Calculate the field at the point p 00z on the z axis. So in the question they are being asked to find out the electric field, elect calculate the field electric field at a certain point 00z due to other point, what can I say, charges lying on a, b, c and d in the xy plane. So the formula that we are going to use, that is directly the Coulomb's law. Ez equal to 1 by 4 pi epsilon naught q1 q2 by r cube, that you are being able to see on the top of the page. The same formula here we are going to apply. Okay, so in this case we have written down 4q by 4 pi epsilon naught cp square cos theta. Actually this is step jump. Here we should have written down one separately, that 1 by 4 pi epsilon naught q by distance square. Four times this will come because there are four charges lying on a, b, c and d. So four times the same expression will come. And why cos theta? Because the point that we are interested to actually find out, on which we are interested to find out the electric field, actually is lying on the z axis, and the plane, the square plane that you are being able to see on my page, abcd, is actually lying on over the xy plane. So there will be a component of electric field due to each point charges lying on ABCD. So cos theta has come for in order to serve that purpose, the component division. Okay, so cos theta. So we have to find out the cos theta by using the simple trigonometric rule that base by hypotenuse. So we have just done that part. You are being able to see one another geometric figure of a triangle. Uh, CPO triangle. So from there, we can see that P point is at the point at the coordinate 0 0 z. So it will be distance. It will be distanced with a distance z from the origin. So your base is z. And one another thing that the side of the square is a, so your hypotenuse, so your perpendicular is a, and from that, what can I say, from that information we can be able to find out the hypotenuse, that is root over perpendicular square plus base square, so root over of z square plus a square. So using all these values, we can be able to find out Ez equal to Qz by pi epsilon naught z square plus a square whole power 3 by 2. And later on in the question number B, they are asking to find out the same electric field if A tends to 0 and interpret it physically. So if A tends to 0, then we have to just put down or write down rather A equal to 0 in the earlier equation, just just we have established Qz by pi epsilon naught z square plus a square. So from there we are being able to find that the final expression that shall come will 4q by 4 pi epsilon naught z square, just putting down A equal to 0. So that's the first type of question from Coulomb's law, directly using the formula of Coulomb's law. And there is another question. A charge q is uniformly distributed over a thin wire of length L. Find the electric field at a point P whose perpendicular distance from one end of the wire is A, and find the field when A very greater than L. So in my next picture, you are being able to see that there's a triangle, and there is a where I have actually drawn namely length L. The base of the triangle that you are being able to see is mainly the where that actually being talked in the question. So from that where in a distance A there is a point P, so we have to find out the electric field at that point P. So we have taken a small elementary length dx on the where based on which we are interested to find out the potential electric field at the point P. So we have to find out since it is a two-dimensional case, so we have to find out the component of the electric field, x component of the electric field and y component of the electric field, and the process is Ex equal to minus integral 0 to L lambda dx sine theta by 4 pi epsilon naught r square. That's also direct use of the Coulomb's law, that is 1 by 4 pi epsilon naught q by r square, distance square. So in dx elementary length, we have taken the charge per length is lambda. So in dx elementary length, the total charge will be lambda dx. So your q is lambda dx, and sine theta, because dx is subtending an angle theta with p, and you are being able to see that the component along AP will be sine theta, sine theta will be involved here, lambda dx sine theta by 4 pi epsilon naught. And for uy component, you know that cos theta will be involved. So from that Actually, I have taken cos theta and sin theta. So the total electric field will be vector equal to Ex x cap plus Uy y cap, just the vector addition, normal vector addition. So just you have to put the values of Ex and dy that you have found out from earlier calculation. So in next question they similarly asked you to find out the value of electric field, the resultant electric field for a very greater than L. So you have to just consider a very greater than L and write down the value for electric field. Okay, thank you.